What's up guys, Alvaro here from Particle School, and in this tutorial we'll try to simulate this effect here. It's created by Lee Griggs and most of you probably have seen it already, so we'll try to simulate this on Particle Flow. First I'll create a plane, and it's very important to keep the faces squared. So I'll make it 100 for 200, and squared I means like it's very important to make these vertices, the horizontal vertices have the same distance as the vertical vertices. Like this vertex to this vertex have the same distance from that one, like this, because we'll place particles on each vertex. And since the particles will be boxes or spheres, it will have the same distance from this side, and this way it will works fine, but it's up to you. So here on this plane I will apply a texture, so I'll press M to open the material editor, and you can apply any texture. I'll just get some of the zinc ones here, because I think psychedelic textures works really well in this case. So connect here, and I will apply it here. Cool. Now let's put some more faces here, and let's press 6 to open the particle view, and let's create the particle system. Press Ctrl X to go to expert mode, and I'll drag a standard flow, and I want to emit all the particles in the first frame, and I want only one particle. We'll create the other particles based on the amount of vertices of this plane. This way you can change it anytime you want. And in this case, we'll start with this kind of low res plane, and then we can increase it later. I don't need a speed, I don't need rotation. In this cube, I want to have a size of 1. And let's show it as geometry. And in this case, it's the first time you can keep the viewport quantity multiplier at 50%. But let's change the render frame to 1. The integration step to frame, in fact. Now I don't want this position icon. Let's replace it for a position object, and let's add the plane here inside the position object and change it to vertices all. Cool. Now we have only one particle, so let's add a data operator here, and let's call it number of particles, amount of particles maybe. And let's create amount change, and let's use a geometry suboperator and get the in fact, yeah, I think it is, and get the object number of vertices. And now we have to say like which object we want to use. So just get a select object suboperator and add your plane here, and then just connect there and there, and now it's fine. So we have a particle on each vertex, and now let's make this size works procedurally as well. So in this case, I want this size now to be here below everything. Let's call this one size and color, because we'll use the same one to make the color as well. So now I want to add a particle suboperator, and I want to use exactly this option here, closest particle distance, because if you see here, I want the size of the particles to be exactly the distance from this one to this one. If you have a look, it will be exactly the size always. So with the closest particle by distance, I want to put it on a output standard scale vector. Now we have a real value here, but if you try to connect real flow is particle flow is smart enough to create the convert here. We just have to link it all here to make it work. It's the x, y, and z values of this vector. So now the size is fine. And if we get this plane here, and let's get the plane here, and let's decrease this to like 10 and 20 here. We have all the exactly amount of particles that we need, and it have the exactly size that we want as well. So let's work with some low values for now, like 50 and 100. It's very important to make it square, because take a look, if it's not squared you can see the plane. So let's keep it like this. And now, but we don't really want to use this z size here in the particle. Let's make the z size based on the color of the plane. This plane here. Yeah, it's the only one. So let's add a select object and get this plane there. Now with the geometry suboperator, I want to get the color of this plane. So let's get the point color. In this point color, we have to specify which object, and it is for the plane, and where, like it's related to some particles. So we need this pair value here. So let's add another geometry suboperator and specify from where we want this point color to be get from based on the particles and the plane. So you have a lot of options like closest objects by closest point normal, and we want to be the closest point by surface. So it will get this suboperator here will get the point, the closest point between the particle and the surface. And since the particle is like right on the surface, it will get that point on this object, and those particles are connected here, just connect to this pair value, and now the suboperator is satisfied. And now let's connect this value here to the z size here of this scale. That's x, y, and z. So let's connect this vector here, and it will convert to real. And now the z height of my particles are based on this color here. So I'll switch it on again. And as you can see, we already have some slightly difference, but it's too slightly, you know. So let's increase these values. Inside the data flow, let's add a function here. And I don't want to use a second operand, and I want to use real. And now let's connect this this convert here to my function and connect it back here. Now I don't want to use this square stuff. I want to use absolute. Absolute will get just this value, this absolute value here. But then I can use this post factor to multiply that value. So let's see it here. Let's try 5, maybe 8, 13, 21. Yeah, 21 is too much, I think. Let's keep it on 13. I'll press Alt F to see my view here. Yeah, I think it's fine like this. Let's render it. Okay, now let's put the color there. The color will be very simple. You just have to use put a output standard and output this value here, this point color there. So let me just undo this. Okay. And I'll put this one here now. And I'll connect this point color. It's getting values of that color there, and we can output this one here as well, not as a position vector, but as a vertex color channel. And now we can create a vertex material. So I'll just create a standard, and in the diffuse, I will add a vertex color. And now this material, we can apply it to our particles. With material static, below everything. Just don't put this on top of your operator, because you have to read this operator first and then the material. So just connect it here. And you will not be able to see it on the viewport, but when you render it, it's fine. And now, yeah, it's working already. And you just have to get now your plane and increase this resolution. I will increase it a lot, like 300 by 600. And then you have to wait a little bit. And now, as you can see, half of our plane have no particles. And that's why we have too much vertices now. If you check here on properties, we have more than 180,000 particles, vertices in fact, and your particle flow by default only accepts 100,000 particles. So let's just change it to 200 and wait a little bit. And in this case, it's very good to keep this viewport low. We could keep it even lower. And no, where is it? I'll use a HDTV, this one. Yeah, now let's just render it. You can use a camera cooling as well to delete the particles you're not seeing, but it's fine like this. You can also make some cool animations with this. I've seen some around. And yeah, it's working fine. So that's it. I hope you like it. And thanks for watching. Bye.